when you get given a complicated equation like this, you can actually use graphs to get to a rough solution. So if you're trying to solve this, what you do is you would draw a graph of y equals this. So y equals this. Draw that graph, and then you would draw this graph here, y equals 0. So y equals 0 is down here, and then try and find out where the two lines cross. So let's just try and sketch this complicated thing here. Just get a rough idea of what's going on. So when you sketch this term here dominates when x is small. So you would guess it to be something like this. Okay, and when x is big, this term here dominates. So it wants to do x to the power of 3, but it has to compromise. So it has to be something like this. Okay, so this is our guess. But it turns out that this whole graph here will look something like this. The curve would go over like this. And then it turns out to be like this. You see, when we're guessing, we are just getting a rough idea of what this thing here will look like. Because of these three complicated terms here, it takes a curve into the negative realm. And then it takes the curve over to the other side. But you see, sketching is still a useful thing to do because it takes you about 5 seconds to sketch. But then for you to draw the actual graph of this takes you about 5 minutes. So sketching gives you a rough idea, but sometimes it's inaccurate because of this curve thing here. When you are older, you would do what's called calculus. You would do what's called calculus, and the calculus will tell you exactly where this curve will be. So for the time being, it's just useful for us to just get a rough idea of what this complicated curve will look like. And as it turns out, this complicated graph here will look like this. Okay, so when x is small, it really wants to do this. It wants to do this here, and our old way of thinking, when x is big, it wants to do x to the power of 3. It wants to do something like that. Well, hang on. Anyway, this complicated graph here will look like this. Now, because you're trying to solve this here, this graph here equals 0. So you've got to do y equals 0, and then draw this graph, y equals this thing here, and then find out where this equals this. So you see basically y equals 0 will be along here. The y equals 0 line will be here. So you are really interested in to answer this question here. This equals this would be these 4 points here. Would be this point here, this point here, this point here, this point here. So these are your 4 solutions. Now, here's another way of doing it. I'm not saying this is a better way of doing it. I'm just saying that this is another way of doing it. So rather than drawing this complicated thing equals this thing here, you could break this thing up into two smaller, simpler lines. So here, add 3x to both sides. So it will be this. Add 3x to both sides. So bear with me. This will make sense later on. And then you've got minus 2 plus 1 over x. Now add this term to both sides. Well, we'll add 2 to both sides. So it will be this. Hang on. It would be 3. Hang on. It would be it would be 3x plus 2, and then here you would have 3x plus x squared plus 1 over x. Now, what I'm saying is that rather than drawing this line here and this line here, you could change the question. You could draw this line and then draw this graph here, and then find out where the two equal. Okay, so solving this equation here is the same as you solving this equation here. So draw this line here and then draw this line here. I'm not saying that this is a better method. I'm saying this is just another method. Okay, so here draw this line and then draw this line here, and it will look something like this. Hang on, it will look something like this. You see, this is our first part, our left hand side here, okay, which is this bit here, okay, and then you got another one up here, and don't forget it goes up like this as well, and then this is a straight line here. We are pretty good at drawing straight lines by now. So a straight line going through here. You see, it crosses here, it crosses here, and it crosses here, and it crosses up here somewhere. Okay, so hang on, let me clear this up. So here, so rather than solving this here, hang on, rather than solving this thing here, okay, you could translate the problem into this. Okay, and it turns out that you see this x value here. If you draw a straight line from here to here, it crosses here, okay, and if you draw a straight line up here, it crosses around here, and then the solution here, well, let me draw a straight line down here. Then the solution here would be here, and there's another solution somewhere up here. I'm going to guess to be around here. So here's another solution here, and it turns out that these 4 points here are exactly the same, no matter if you look at this graph or if you look at this one here. You see, can you see that the x hang on, if you look at this here, the x solutions are exactly the same, no matter which graph you look at. So you could look at this one here. You see, the x here would be the same. Well, the x here, the solutions are here, 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 and here. Now, if you choose to do the other one, it would be the same. The solutions are here, 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 and here. So it doesn't matter which one you use. It will give you the same solution. So here, hang on, bear with me. So let me clear this up. So here we can try and work out where these points are. Okay. So here you would then jump to a table. So you would create a table like this. Okay. So this bit here, hang on, bear with me. This thing here is this blue line here. Okay. And this bit here would be the straight line here. You see, so you would create a table with lots of different values here, and then try and find out where they cross. So if you try and plot this thing here, okay, this bit here, if you put 0 into this bit here, put 0 into this bit here, put 0 into this bit here, and it will give you this here. Well, as it turns out, that the first value would be infinity. Okay, infinity is just a concept. It's just to say that the answer here is really, really big. It's infinity. It's a really big number. Okay, negatively big. So infinity could be really big up here as well, or it could be really, really big, but on the negative side as well. Okay, so you would create a table like this. So now put 2 into this, 0.2 into this thing here, and it turns out to be somewhere around here. So my point here is, if you want to find out where this would be, then create a table like this. So when x is 0, it's infinity, somewhere up there. When x is 0.2, you see this blue line here is above this green line here. So hang on, when x equals 2, it would be, the blue line would be here. So when x equals 2, it would be 5 point something. When x equals 0.2, this thing here will be below this. You see this value here is below this value here. Okay. Now when you move to 0.4, it would be somewhere here, and the x here. Hang on, let me think. When you move into 0.4 here, you see there's a switch over. Hang on. Let me start again. When x is 0.2 here, this blue line here is 5 point something. So, and then this green line here is below. Now when you move into 0.4 here, the blue line is now below below the green line here. It's below this green line here. So you must know that there's a switch over somewhere. Okay, let me start again. When you're at 0.2, the blue line is above the green line. This is the blue. This is green. Okay. Now when you get to 0.4, you see this this blue here is smaller than the 3.2 here. So the blue is smaller than the green. So there must be a switch over. Okay. I will continue explaining this in the next video. My battery's running out. Sorry.